Hello and welcome back. My name is Mike Price. We are discussing section 1.4, functional models. Learning objective for this video will be to study general modeling procedure. So the word modeling has a lot of different meanings in a lot of different contexts. If you're thinking America's top model, probably not the kind of modeling that we're working on right here. So mathematical modeling is basically this probably the hardest thing that you ever do in a math class, unfortunately. It's the process of taking English and making mathematics out of it. So I've made this argument in a previous video, but although this is one of the more challenging things we can do in mathematics, it may also be the most valuable thing because it's the least likely thing that a computer can take over for us. Wolfram Alpha graphing calculators can graph beautiful functions for us, they can solve very complicated equations for us, they can simplify expressions, all sorts of great things. What they're not perfectly good at doing is taking English and making math out of it. So while human beings stay ahead of the curve on translating, we might as well work on that particular endeavor, challenging though it may be. So we'll take a fairly straightforward example, but one that maybe illustrates what we're after. So we're going to think about phone companies and their texting plans. So one company, C-Mobile, charges you $5 a month and then charges you 10 cents per text message. Ooh, $10 per text, that might discourage you a little bit. Verizon charges $10 a month and there's no limit on how much you can text. Or, well, more precisely, you don't get charged for texting. So the question is, when is the C-Mobile plan a better deal? Maybe when is the wrong interrogative to use here. It's not about time, but maybe it's about how many text messages you send. So the first task for us to accomplish is basically to figure out what these charges look like. And the only thing that varies between these two different deals, and we can revisit it for a sec, the only thing that varies between these, it's not time, because it's still monthly plans, and the things that vary are how many text messages you send, and how much it costs you. And a function of one variable is very good at relating to things like that. You have some input and some output. I think in this case it makes sense to use x, how many minutes you operate, or how many minutes you, how many text messages you send. I suppose this could also be about how many minutes you talk, but how many text messages you send as the input, and then the cost, and I've used m just to differentiate the cost function for C-Mobile as opposed to the Horizon plan that we'll see in just a minute. So things to think about are basically that we know we're going to get charged $5 a month no matter what. So this is a good key for a constant in our function. So $5 is going to happen every month regardless of the number of text messages that are sent. And then we have basically the variable cost component. This is the piece that actually depends on, I guess in another scenario, how much we produce. In this case, it's how many text messages we send. So if we send X text messages, it's going to cost us $0.1, that is 10 cents, times however many text messages. So our total cost function comprised of fixed and variable cost looks like this, 5 plus 0.1x. For Horizon, it's actually less interesting. There isn't any X component to this. So if you recall, the plan there involves no fee per text message, so there's no component with X. You could imagine this being written as plus 0x if you'd really like, but the $10 fixed fee per month, that's all there is. So you can see the interplay here is basically that this is a larger fixed cost than C-Mobile's, but this has a component that rises with the number of text messages you send. So probably there's a point at which this plan becomes not as good, even though it starts out at $5 as opposed to 10. So this is just thinking about what it means to get a better deal. So a better deal in this case means that C-Mobile's monthly cost is less than Horizon's monthly cost. So now we just replace these expressions. C-Mobile, we have an equation for that. We have an expression that represents this function's rule. And then we've got something similar for Horizon as well. We've got this right side, which is fairly simple, but all right, don't knock it. No judgment here. It's just 10, constant function. So once we're here, this is pretty much the point at which most math problems start, at least if your experience in math to this point was anything like mine. This is where the equation or inequality in this case begins. But there was so much more lead up to this. Getting these equations to begin with, making the argument that this inequality is actually the most worthwhile thing to look at, that's all part of the mathematical modeling process. Here, from there on out, these last couple of steps, sure, they're useful, but a computer could do this for us. If you ask which of these two plans is better, Wolfram Alpha is just going to kind of stare at you, which is really awkward when a piece of browser software stares at you. That's kind of disturbing. Anyway, so we can do a little bit of algebra here. We can subtract 5 from both sides. That gets us down to 5 on the right. And then we can divide both sides by 0.1. And once we do that, dividing by 0.1 is the same as multiplying by 10. So there we are. X is less than 50. That's not actually the answer to our question, though. X is less than 50 is the mathematical result here. But what we really need is something in words that describes what's going on. So X is the number of text messages we send. It's saying we should be less than 50. And remember how this started. C-Mobile is a better deal when, and then we follow this all the way through, C-Mobile is a better plan when X is less than 50. That is, if you send fewer than 50 text messages, C-Mobile is going to charge you less per month than Horizon would with their unlimited texting plan. That's it for Learning Objective 1, Video 1 for Section 1.4. We'll see you again for the next